So this is a follow-up to a talk that I had in New York in May. And it's a status update for enabling IPv6 in Cloud Foundry and showing you how far we've gotten so far and what we want to do next. There's a few things that I want to show. The plan and status of IPv6 enablement overall at SAP. And again, this is an update to what I've shown in May. A bit more about dual stack ingress support, specifically on AWS, and the work and research we're doing towards dual stack egress right now, which then spans various components, including Bosch, Diego, and the different hyperscalers. And finally, how we actually want to continue, and this is then a call to participation as usual for contributions and so on. So, the current status. This diagram was shown in May already. The point was a little bit further to the left, now it's further to the right. We're progressing, that's good. On the ingress side, we now have on AWS an IPv6, or rather dual stack ingress that works. And the migration path is clear, which wasn't clear yet. So now it's clear. I'm also going to show a few things about that. And we're now testing other things that we run on top of Cloud Foundry. As SAP, you know that we provide a bunch of services. Many of those run on top of a Cloud Foundry foundation, which we then call a business technology platform. And testing of that starts now. And at the same time, for egress, we've now done the initial canvassing to see what work needs to be done, and it's pretty clear that there's a lot of work to be done. We basically need to introduce dual stack in pretty much any component that somehow touches something with incoming requests. And one of the next steps will be to document that, the findings that we have with the community, and start collaborating a bit more. About dual stack ingress. And this is specific for AWS, because AWS has this load balancer that does magic translation from v4 and v6 to whatever your target group is, so in our case v4. And that's all great, but usually you then lose the client's IP address, the original client's IP address. There's something called transparent proxying that will retain this client IP address, but unfortunately that only works for one of the V's. So either v4 or v6. And AWS has something for that, of course, which is called, well, HAProxy has something that is called proxy protocol. AWS load balancers support that. And with that, we can actually get the information of the original client's IP address through. And this is important for the migration step of actually enabling IPv6 or dual stack on a previously IPv4 landscape without any downtime, where we need to somehow distinguish requests that are coming in through a load balancer that is already IPv6 enabled versus the ones that where it isn't yet. And we can do that by turning off transparent proxying, which will then expose the client's, the load balancer's internal IP address. And we can just filter out those requests and dynamically expect proxy protocol for those, but not for the others. If you have more questions on that, I'm around. I don't want to go into too much detail because there's also very little time in this slot, unfortunately. And there's a lot more to talk about for egress. As I said, there's a bunch of components that are involved. First one that I want to talk about is Bosch, where Bosch itself, the Bosch director, Bosch agent, CLI and so on, can do either or, so v4 or v6, but not both at the same time. So our goal will be there to introduce dual stack. And work on that is already starting. There's research going on, and the first step that is actually in progress, or very, very soon in progress, is actually the CPI, so the cloud provider interface, that instantiates the VMs that then do things where you can deploy stuff on, to include IPv6 addresses in addition to the v4, so enabling dual stack. In the stem cells, we have dual stack enabled by default in Noble. In Jammy, you can enable it. It's a bit of a hacky workaround because you need to restart the VM once you deploy it, but it would work. Recommendation is though that to use Noble if you can for this. And Bosch Agent, we're also investigating how and where dual stack support would be needed. The hyperscalers overall broadly support dual stack, some better, some worse. A bit more on that in a couple slides. But first, let's move on to the container runtime. So Diego, Silk, all of the goodness that you've heard so much about today. All of those components need to be able to handle IPv6 information somehow as well. The Diego cell, because it's just a VM, you can somehow enable IPv6 on that. You can do that now. You can just go into SSH and enable it. Ideally, you would do that via Bosch. So once Bosch has dual stack support, we can get that. Great. Next step will be runc and garden. Runc is the fundamental containerization library that pretty much everybody uses. I think it's partially also behind Docker and so on. So that one does support IPv6, that's no problem, but we have garden on top, and that doesn't know anything about IPv6 at all so far. So work there needs to be done, and our container runtime team is working on that. They have a proof of concept currently going, where they want to just show some request going through to an IPv6 endpoint. Then what we heard various times already, including from Tamara, BBS somehow needs to also retain information about the routes, and the routes will eventually also include IPv6 endpoints, which means that this type of information will need to be passed through and stored. Envoy should support IPv6 by default. And my big elephant in the room is Silk, because Silk doesn't know anything about v6 right now, doesn't support dual stack, and the idea is, or was, to maybe get rid of Silk or just work around it, but it's very deeply ingrained. So a lot of things in launching a container actually talk to Silk, and replacing all of that wholesale will be a lot of work. So we'll see how we go about that, whether we improve and extend Silk first, or if we try an alternative way, but that's still up in the open. Right. There's, of course, some additional resources, because there's now different address types, or you have two types of addresses. There's some more firewall rules. There's more information in the actual workload data that you store and process. Potentially higher resource consumption because of that, but the exact scope of that is something that we'll still need to check. Okay, and coming to the hyperscalers, and primarily talking about AWS, because that's where we're actually testing stuff right now, or where we're focusing on. Partially also because this is where we can test on right now. Support is pretty good. We have publicly routable addresses for pretty much anything you want. So our goal of having per container IP addresses is very feasible with this. Great. Ideally, we wouldn't want people to just circumvent and go from the back into some container's IP address and just send requests there. And AWS has something for that. It's called egress-only internet gateway, which basically is a firewall that stops incoming traffic that is directed to one of the app containers, but allows the app container still to call out. On GCP, this magic thing that I was saying about the load balancer that it auto-translates doesn't exist. Neither does it on Azure, and that's fine. There is IPv6 endpoints and available and so on, sure. But what we need for that is Bosch to support dual stack first. So this is also partially why we haven't moved to GCP yet. And Azure is a bit of a longer story. They have various things that are missing for good IPv6 support. But we have from credible sources that Microsoft is working on those. Okay, to conclude, or how we want to move next. I've presented a lot of things that are so far internal. That's partially also because this is very fresh. This is also was the goal of my talk, to give you the latest available information that we have. And one of the next things will be to write these things down a bit more and open GitHub issues to provide an overview of the things that we want to do, which will very likely end up in an RFC, to also discuss how we want to go about actually adding IPv6 support to Cloud Foundry overall, and then ask for comments, contributions, and so on. The CF IPv6 channel in the Cloud Foundry Slack is still open and available. After the initial hellos in May, not much has happened yet, also from our side. But I hope that very soon that will change. And to quote Wayne, IPv6 or bust. Of course, I can't go away without saying thank you to our teams that actually did most of the work that I present today, which is our AWS Hyperscaler team. Reach out to Georgi. Our Bosch team, reach out to Max, who is, I think, not here today, but that's his email address, and he's on Slack. And the Container Runtime team with Plamen. Thank you.